Hey guys, welcome back. Hope you all are doing well. This is Mohammad Badrudduja, and today we are going to solve the last lab number 7 from the server-side request forgery module. Again, this is a server-side vulnerability, and if you are watching this video and you did not watch the previous video of this section of this module, please go back and first of all watch those videos and try to follow the process with the lab. Right, so you must have the mindset, you must have the prior knowledge, what is SSRF, how you can spot it, how you can test it, and how it does work. After that, you can come to this lab and you can try to understand. So in the previous lab, we already spotted blind SSRF, and to test it, we actually adopt an approach which is out of band interaction. And we will come to that point in a minute, but before going further, this little disclaimer: as always, this video and its contents are only for educational and awareness purpose, and I do not support any unethical or illegal act. That's been said, I highly recommend these labs from the Web Security Academy from Portswigger if you are interested in web application penetration testing, because it gives you a lot of study material with the labs and with a very strong fundamental platform, right? So that's been said. I was talking about out of band interactions, so I just want to brief a little bit about this, what is out of band interaction. So actually, blind vulnerabilities are difficult to spot because you cannot see the expected response returned to your browser or rendered into your browser. So that's why it's known as blind vulnerabilities. So you must trick the server to send the request to your controlled server where you can capture or intercept the traffic, and you will know, okay, I'm getting hits from the expected source. That means that server is sending the request to me, and there you go, means the server is vulnerable. So that is the out of band interaction. Okay, in the previous lab we already spotted the blind SSRF vulnerability. We detect that, and in this lab we are going to exploit that or weaponize that blind SSRF vulnerability to actually exploit the Shellshock exploitation, or to exfiltrate the data through Shellshock exploitation. Because this is very difficult, first of all, to spot the blind SSRF or any blind vulnerability. It's difficult to spot. Second thing is, if you even spot the blind SSRF vulnerability, it's difficult to exfiltrate the data. So because nothing is very much crystalline clear in front of you, with blind SSRF vulnerability you can manage somehow to interact with the internal subnet of the server, and then you can scan the internal subnet and you try different vulnerabilities. So if in the internal network there is any unpatched system or server which has a vulnerability, so you can exploit that vulnerability. Fine. So that's been said, we will see all these in this lab. But before going further, again, what is Shellshock vulnerability? This is another type of vulnerability, and this vulnerability mostly exists in the bash, and this is actually spotted as the bash bug, where you can execute the commands as a privileged user, or you can execute the privileged commands which normal user cannot execute. So that's been said, let's go. I'm going to just read this agenda so we will know what is the scenario. This site uses analytics software which fetches the URL specified in the referrer header when a product page is loaded. So whenever a product page is loaded, you will see the referrer header in the request. To solve the lab, use this functionality to perform a blind SSRF attack against an internal server in the subnet of 192.168.0.x. So there is an internal server which is inside the internal network of the server which you are going to target for the blind SSRF, and this internal server publish an internal application on port number 8080, and this internal server is vulnerable to Shellshock vulnerability. So in the blind attack, use Shellshock payload against the internal server to exfiltrate the name of OS user, right? So we need to create a Shellshock payload where we are going to execute the command on this specific server. Okay, but here you can see we know the subnet, but we do not know the exact IP address of that subnet, of that server which is vulnerable to Shellshock. So we will do some kung fu things here. Let's go. This is the lab, fine, and this is my burp suite. And today you are going to realize why burp suite is the first choice for the most of web application penetration tester. Now suppose okay, once the condition arises, at that instant I will tell you. First of all, I'm not advertising anything. I'm just sharing my experience with you. So okay, I'm going to enable the burp proxy on my browser, and let's just access few things. Now refresh the page here, or go to the home, and here go to the proxy. Intercept is off. Go to the history. Here you can see you have the request, right? Here you have referral header also. Fine, that's it. If you go to the target, here you can see you have the same target here, and you can add this target to scope, but I'm not adding this target to this scope right now. But I just want you to see this scenario on this target. You can see if burp suite detect any kind of issue, it's going to put that issue here, and it is going to give you the explanation about that issue in this section, in the advisory section, right? Okay, now let's go again, and here I'm going to open a product. So once I open the product, you can see there is a product request, and in the product request we get the referrer header. Also here we get the referrer header, and in the previous lab we actually spotted the vulnerability through this referrer header. Now the thing is, maybe this application has tons of features, and as you can see here, once you just click to home, there are two requests, right? You click on one page, you visit one page, but there are two requests. Maybe in real world scenario, maybe you will see here 10 requests, because maybe Java scripts are running there, and jQuery and other scripts running in the backend which fetch something from another point of the server. So at that instant it is very, very difficult to actually go manually to all the requests, to all the features, check the request, and try to put the payload or try to check each header for the SSRF. This is very, very difficult and overwhelming. So at that instant, now why burp suite is too good, because it gives you a lot of flexibility and features, trust me. So today I'm going to show you a plugin named as Collaborator Everywhere. So once you go to the extender and go to the app store here, and just write it here, Collaborator Everywhere, and once you write here Collaborator Everywhere, here you will find that Collaborator Everywhere. Now what this Collaborator Everywhere do, it actually, once you add the target in the scope, at that instant this plugin automatically add headers in each request and test the ping back for you. And if this any request get the ping back, you will get the issue here and the explanation of that issue here, and you will see that in a minute. Now you can memorize this window for a little bit time, because you are going to see changes here. Okay, now I'm going to add this in the scope, fine, and here you see a little window: filter, hiding not found items, hiding CSS, image, and general library, general binary content. So right click on it and just click on show only in scope items. So this will ignore the rest of the other requests generated by the Mozilla Firefox or anything which you are using. Fine. Now again go back to the proxy, and now come here and again try to click on home. You get here a request, and that seems very normal. Okay, try to click on any of these product, come here, click that request, and it's very normal, nothing is there. So plugin is already installed, but you do not see what I said, what I mentioned, that the Burp Suite is going to add additional headers here and payloads here, and to check each and every request. And the effect you will not see here, you will see in the target. Once you go in the target, you can see here a little red alert signal comes here. And as I mentioned before, memorize this window. Before there are not collaborator ping back. Before there is no collaborator ping back, but now you see here collaborator ping back, and there are DNS and HTTP requests are there. Now click on any of these. Let's see, you can see here once you drop down, you see /product. So click on this product ID. Now this is what Burp Suite sent. So if you go to the proxy, here you can see it's very small request, there are not much headers, but go to the target and here click on this request and you can see. So now client IP, true client IP, forwarder, right, X forwarded for, CF connecting IP, contact from X client IP, all these non-standard headers are added by the Burp proxy through the Collaborator Everywhere plugin, and that plugin did wonderful job, and you can see here you got ping back. So once you click on any of these, you can see it's telling you that there is a issue, there is a vulnerability, and the severity level is medium. Okay, and the issue is you are getting the ping back DNS request through the referrer header, and here you can see the HTTP request you are getting through the user agent. So there is user agent, you can see this is the normal user agent up to here, but the Collaborator Everywhere is adding this payload in the user agent. Now what we can do here is now we know that okay, there is blind SSRF through the referrer header, and we can use user agent to actually execute the Shellshock payload or Shellshock exploit we can execute through this user agent. So go back to the proxy, send this request to the intruder, go to the intruder, position, clear all the positions, and in place of referrer header, I'm going to say http://192.168.0.1 port number 8080. That's been given by the lab, right? Yeah, port number 8080. Now the next thing is we need to create a payload, Shellshock payload. So I'm going to do that. Okay. So user, as I mentioned before, this is a bash bug. Executable binaries in the user bin / I'm going to execute nslookup command. Fine. And to solve the lab, what we need to exfiltrate? We need to exfiltrate the user. So what I'm going to do here is, this is a bit bash script. So who am I, right? So user you get with who am I. This is my terminal. Okay, if I say /user /bin /who am I. So who am I? I am root. Root is the user, right? I can also execute this command by saying just who am I. But the thing is, Shellshock is a vulnerability because you can execute command as a privileged user, or privileged command you can execute. So that's why I'm going to use user bin ns lookup here, and who am I, and after who am I, I'm going to do one thing, which is I'm going to the burp here and go to the burp collaborator client, copy the burp collaborator domain, and come back here, just paste that. So this is going to be my payload. Take this payload, come back to the burp proxy and your intruder, and instead of this user agent, I'm going to change it to the Shellshock payload. Right now here, because as you can see in the agenda, we don't know which internal server has this vulnerability, but we are testing this vulnerability across whole network because we don't know, we cannot scan the whole network for all the ports, for all the vulnerabilities. We don't have much surface to find the attack vector. So that's why we are going to test this vulnerability across whole network. Maybe there are Windows machine, so this is not going to work on Windows machine. There are maybe more Linux machine or Unix machine, but they are patched, so that vulnerability is not going to work on them. But the server which is unpatched, it is going to work, and we will get that. So come back here, come on here, yeah. So I'm going to add this one as the payload point where we insert the payload. Now the attack type sniper is okay, go to the payload, and here I'm going to use payload as number because we need to change the IP address from 1 2 3 4 up to 254, because the last valid IP is 254. 255 is the broadcast IP. So every time it is going to increase 1. Now maximum number of digits going to be 0, maximum friction digit 0. Why? Because you don't want the decimal, so just make it 00. Now there is no decimal. Okay, just start the attack, and attack is started. Put the collaborator client here. It is going to execute the payload, and here you will see the DNS request, or the actually DNS request, not the HTTP request, because we use ns lookup command. So ns lookup will send the DNS request to resolve the name, but it's not going to send you the HTTP request. So it's approximately done. Yeah, up to 254, it goes up to 254, and now you can see here we got 2 DNS requests. So once you go to the DNS request, you can see here the domain name is peter-xr30c5 and then your collaborator name. Now I'm going to copy this and will let you know what exactly this is. So here you can see this is our burp collaborator domain, right? And here is your burp collaborator domain, and we make the ns lookup command for this domain, but we put here, before executing ns lookup, we also add here who am I. So who am I means I am asking for the user, so it gets the output of who am I command and put that output here, and then make one dot, put one dot, and then the complete domain name. So this is the result of your command. That means you can execute command on that server which exists in the internal subnet of the target server. And to complete the lab, just copy that. And one more thing, please do not submit this to your lab, because for you it is going to be different. So come here, submit solution, paste that, click OK, and we solve the lab. So congratulations, you solve the lab, you understand everything. Even if you have any query or you have any confusion, please put your query in the comment section and I will try to resolve it as soon as possible. That's it for this video. If you like the content, please like, subscribe and share. See you in the next video. Bye.